Hi class, so this is my example for chapter 14, analysis of variance, where we're doing a between subjects one-way analysis. So this is the ANOVA fun table that we'll start with and we'll work from for our step 3. This is the data I have for you, so I'm making it very generic in that we have 3 different treatment conditions. Each condition has 10 people in it. Again, it's a between subjects design. I then give you the sum of squares for each of the 3 treatments, so that's your sum of squares within. And I give you some means to make a general comparison. Again, since each of the 3 different conditions, each has 10, our total, big N, is 30. So we're going to be using some of this data to be moving forward with some of our steps and calculations. So the first thing I would say is go ahead and pause and identify your step 1 and step 2. So step 1 is setting your hypotheses, your null, and your alternative. Remember that we use words in math for the null. We only use words for the alternative because ANOVA is an omnibus test. And then you're going to go ahead and calculate your degrees of freedom within, which is the numerator for your F table, and the degrees of freedom between, which is the denominator for your F table. And then you're going to find that critical value for an alpha of 0.05. And now we're going to keep moving forward for step 3. So step 3, again, is our ANOVA fun table. And I had given you the SS total. Remember, SS between plus SS within is your SS total. You were also given the 3 different sum of squares withins. So you are going to be now working with your ANOVA fun table. So if you remember, for degrees of freedom between and degrees of freedom within, you would have already calculated those, or add those 2 up that you calculated in step 2. So now take a moment to work through your ANOVA fun table, and then we will check our work and move on. So here we are, we've worked through. Again, you were given the sum of squares total, you got the sum of squares within, and then you use those 2 to get the sum of squares between. Then your degrees of freedom we figured out in step 2, and in step 2 you also had identified your critical value, and you are now ready to figure out your variance. So you're going to be calculating the variance between and the variance within. So sum of squares over degrees of freedom equals variance, and then we're going to move forward to our F. So go ahead and do those calculations and then check your work. So again, you could also be looking at the handout that goes through the 5 steps. We calculated the variance between and the variance within, and now we're going to get to F, which is taking your variance between over your variance within. So 10 over the 2.44 is going to give us our F value. So this is our F value in step 3 that we then would compare with our critical value we got in step 2. So we can go ahead and take a moment to review our findings. And so when we compare the 4.10 to our 3.35, which was our critical value from step 2, which you also saw in the handout, we see that you do your 3 statements. So reject the null. It is statistically significant. And then because I left you a generic result, we can just say there's group differences on the DB for treatment on the DB. But again, if you had context, you give me context. And since we reject the null, we do a post hoc. If we fail to reject the null, no post hoc. So we would do a post hoc. Again, you're not doing those calculations, but you would know you'd pick your stats program from a Tukey, a Bonferroni, or Chaffee test. So then the next thing we need to do is step 5, which is our eta squared. And so again, you had your formula, you're just looking over your SS between over your SS total. So again, if you hadn't done that, take a pause. And if you had, you'd go ahead and do 20 divided by 86, and you get 0.23. 0.23 is a medium effect. when you look at your small, medium, and large sizes. So this is something that you'd want to put on your cheat sheet or your notes for your next exam. And then that is a medium effect. And what that means is of the variance that's going on, 23% of it is due to your treatments. So 23% of the differences or variances you see in your DV is accounted for from your IV or your factor or your treatments. So I hope this extra example was helpful. Thanks.